Welcome to Physics 30 Prep Fast Track, lesson number 6, Kinematics Formulas B. All right, this is just the second version or the second installation of these 4 kinematic expressions I give you for acceleration. So let's continue and say, all right, here's lesson 6, Kinematic Formulas B. All right, let's get to it. And we have a velocity time graph here. All right, remember, the slope of a velocity time graph is what? The slope of a velocity time graph is the acceleration. What about the area under the curve? The area under the curve is a velocity time graph is displacement. And we can use this idea to create another formula. And that formula is based on the area under the curve. Right? If you look at the area under the curve in the picture, that shaded area is 10 seconds wide and about 12 or 12 and a half seconds high, or meters per second high. And so you could figure out the area under that curve if you had a formula for area, and of course we do. Area is equal to 1/2 times base times height. All right. There's other versions of the area of a triangle, but that's the basic form. 1/2 AB sometimes is used. So since d is equal to vt, distance, we want to find the distance. We need the average velocity, and what happens here is when you want the average of two things, and one of them is 0, for example, your average age. If you're 25 years old, or let's make it easy, 24. What's your average age? Well, your average age is 12, because your initial age when you were, born, your age was 0. All right, or 2 minutes, but essentially 0. And now you're 24, and so your average age is 0 plus 24 divided by 2 is 12. All right, that makes you feel good sometimes. If you're 52 like me or so, my average age is only 26, so that's pretty good. Anyways, by using the formula for distance, which is speed times time. All right, I'm just using my formula v is equal to d over t. Solving it for d, I get v times t. And then average velocity is the initial plus the final. The initial in this case, if you look at that velocity time graph, notice that the initial velocity at 0 time is 0. It's down in the corner there. And then as the time goes, the speed picks up. And so the final velocity is somewhere up around 12 or something like that. We won't use numbers, but you'd go 12 plus 0 divided by 2, and then times the time. Average velocity times time will give us the displacement of that object. All right, and you could do the same thing if you took that and found the area of the curve. So the area of the curve equation at the top, a is equal to 1/2 vh, and the formula d is equal to vf plus vi over 2 times t is essentially the same equation. All right, so the product of average velocity and time gives you the change in position. All right, all these arrows just point to different things. The time and the average velocity is, of course, final plus initial divided by 2. It's a little different than the last concept when we were doing final minus initial. That was the change. To find the average of two things, or the average of 10 things, you would add up all those 10 things and then divide by the number of things. In this case, we've got initial and final. There's only 2, so we add them and divide by 2 to get the average. So here's our second equation already. All right, so it doesn't take much to develop these equations, and now you have this. And this will be on your formula sheet. When you write an exam or a quiz in Physics 20 or 30, you will have this equation on some little corner of the sheet in a little box with a couple of other ones, like v is equal to d over t, and the one we just developed in the last lesson, a is equal to vf minus vi over t. All right, so now we have an equation. Let's do a couple of examples, and then you can try some more later on your own after we've developed the other equations. Okay, so the following are practice equations, or practice questions with the second of the 4 expressions. d is equal to vf plus vi over 2 times t. So a cyclist accelerates uniformly from rest to 6 pointed. So this is very similar to the previous question. I use the same examples, but there are different numbers and so on. cyclist accelerated uniformly from rest. So now you know initial velocity was 0, final velocity you can see 2, 6.8 meters per second, and the time was 4 seconds. I think last time we asked what's the acceleration. This time we're asking what was the displacement of the cyclist. So how do we figure out the displacement? Well, as you can see, we've got initial velocity right here. We've got final velocity right here. And this is what some of my students actually do. They take a highlighter, and as they're reading a question, they highlight the important information. All right? So there's a strategy. It doesn't have to work for you, but some people find it helpful. Anyways, now you can see that the rest goes up here. All right? And the 6.8 goes right here. And of course the time goes right there. And what you've got is the solution, because now all you do is substitute. It becomes, in a way, sometimes I call it cookbook physics. In a way, it's simple because all you need is the right ingredients, and the ingredients in this case are the rest is equal to VI, and the 6.8 is equal to VF, and the 4 is equal to T. And so if you put in the right ingredients in the right place, out pops a nice little recipe. And so it's kind of cookbooks, plugging it in. The proper term is substitution, and that's okay. It's a good skill. As you get more into physics, these things get much more complicated, but this is a good start. All right, so that's the solution. And when you plug in those numbers by substitution, you should get about 13.6. Now the reason I say about is because you might end up with a whole bunch of extra numbers. And right now I'm not really applying my proper sig digs. I should only have 2 sig digs in my answer, but I'm not trying to confuse you. I'm just saying the answer should be close to 13.6. If you get that, you've done well. We'll worry about the sig digs a little bit later. All right, another example. In this problem, you'll have to manipulate this formula, d is equal to vf plus vi over 2 times t, and solve it for t. So t is equal to 2d divided by vf. Now how did I do this? Well, I basically took this and flipped it over and multiplied it then over here. When you want to divide by something, you multiply by its reciprocal. So I basically multiplied d, which is here, by 2 times the, 2 is down here, now it's on the top. And VF plus VI used to be on the top when it was on the right-hand side of the equation. Now it's on the bottom. So simple algebra. And some of you may not think that it's so simple, but you need to keep working at it. At this point, it's sometimes good to find a student that you can work with, or someone in your group of support that can do some simple showing of this particular skill. All right? It only takes a few minutes sometimes, and it can be very helpful if you're struggling. Or you can get a hold of our online tutors, or even contact me by email, or whoever is coordinating this course. It may not be me. All right. Example. A car was accelerated uniformly from rest to a final speed of 30 meters per second. How long did it take the car to accelerate if it traveled 120 meters? So again, you can see that we're starting from rest, so our initial velocity is given as 0. A final speed of 30 meters per second, there's our final, and it travels 120 meters. Oh, there's our d. So they've given us 3 of these, but they haven't given us d. They haven't given us t. So what are we going to do? We'll manipulate this formula and solve for t. And the way to do that would be, first thing, multiply both sides by 2, and you get 2d. Then divide both sides by vf plus vi, and there's your vf plus vi there. All right, so it's like I said, straightforward process. When you do that, 2 times d would be, of course, 2 times 120 divided by vf plus vi. Well, vf is 30, vi is 0, so 2 times d 2 times 120 is 240. 240 divided by 3. Well, 24 divided by 3 is 8. And there is your solution. So try that. And, once you get the manipulation down, the substitution is the fun and easy part, if there's such a thing. All right. Another example. In this problem, you need to solve or manipulate the formula for the unknown, in this case, VF. So we start with D is equal to VF plus VI over 2 times T. That's our basic equation. That's what you'll find on your formula sheet. But in this particular problem, you need to manipulate this formula and solve for the unknown. In this case, the unknown is VF. A train was accelerated uniformly from 10 meters per second over a distance of 500 meters for a period of 20 seconds. What was the final speed? So when you tear apart this question, 10 meters per second, well, that means we started there, that's VI. So this time it wasn't at rest, it was moving. Over a distance of 500 meters, well, that is D. For a period of 20 seconds, that's the time. So they've given you 3 of the 4 variables. The one that they didn't give you is VF. So we have to manipulate this formula and turn it into a formula that is solved. That means isolate VF on the side. And everything else goes to the other side. So you can do this by multiplying both sides by 2, dividing both sides by T, and then what you'll have, if you divide by 2, you'll move the 2 up by the D. If you multiply by 2, you will move the 2 up by the D. If you divide by T, then that'll move the T below the D, and then you'll have VF plus VI. And of course, to get rid of the VI, what do? You subtract it. And so you'll be left with VF is equal to 2D over T minus VI. And when you substitute these values, you will get 60 meters per second. All right? These are excellent examples. You'll notice that they are sort of the same theme. All right? Get enough information to do the problem. You just have to figure out what it is they're saying, and then break the question down into these little parts that you can manage. All right? Don't try to do the whole thing in your head staring at the page, because that's not going to work for you very well. And if you write things down, if you draw pictures, it will become much easier for you. All right? That's it for this equation. So you've got 2 down, 2 more to go.